Most telescopes are either firmly planted on the Earth or floating in space. There is one NASA mission, however, that flies in between. SOFIA, the Stratospheric Observatory for Infrared Astronomy, is an infrared telescope built into a 747 SP jet airliner. It enables research not possible with any other telescope. Flying at 39,000 to 45,000 feet, SOFIA is above 99% of the water vapor that blocks infrared light from space, so its view is nearly equal to a satellite's. But unlike a satellite, its instruments can be upgraded and replaced, just like an Earth-based observatory. And with each upgrade, SOFIA's powers increase. Currently, its sensitivity and resolution are similar to some infrared satellites. However, a new instrument is about to help astronomers reach SOFIA's maximum sensitivity at far infrared wavelengths between 25 and 122 microns. Called HIRMES, the high-resolution mid-infrared spectrometer is not designed to take pictures, but rather make incredibly precise measurements of specific far-infrared wavelengths emitted by oxygen, water, and hydrogen. Seeing how these atoms and molecules are distributed around a young star is crucial for astronomers to better understand how planets form. HIRMES is being built by a team led by Harvey Moseley at NASA's Goddard Space Flight Center. Goddard is one part of the large collaborative effort that makes SOFIA possible. NASA's Ames Research Center manages the program, the Armstrong Flight Research Center maintains and operates the aircraft, the German Aerospace Center maintains the telescope, and many other institutions and organizations contribute their expertise and instruments. HIRMES will observe light with wavelengths 30 to 160 times longer than the reddest red humans can see. To do this, the instrument's detectors must be made extremely cold so their own heat doesn't overwhelm the infrared light of the objects they're observing. Because SOFIA lands after each observation period, its coolant can be refreshed, allowing HIRMES to operate at less than a degree above absolute zero. At this temperature, even slight movements can generate unwanted heat. Vibration is a part of any airplane flight, so SOFIA has a complex system to isolate it, eliminating any potential problems from heating and preventing blurry images at the same time. By looking at stars with protoplanetary disks, HIRMES will see far infrared light, marking the presence of neutral oxygen atoms, water, hydrogen, and other molecules. Because water vapor and icy particles emit different wavelengths, researchers can locate where the water vapor transitions to ice in protoplanetary disks. These transition regions have not been well explored in young planetary systems because ice emissions are difficult to detect. Finding ice particles is one of HIRMES' key missions. Putting all these observations together will help scientists better understand how water vapor, ice, and oxygen combine at different times during planet formation. This, in turn, will help us better predict exoplanet composition and give us clues as to which distant planets are most similar to Earth.